All right, we are going to do part 2 of chapter 7, lesson 2, which is working with negative exponents and zero exponents and how to simplify expressions using those. So I want to show you a proof of negative exponents so that we can get to an understanding of how this works and why this works. 2 to the 4th is 16. 2 to the 3rd is 8. 2 squared is 4. Can you see a pattern developing here? This number is half of this. This number is half of this. So if we just use the pattern rather than using the multiplication over here, we would have 16 goes to 8, 8 goes to 4, 4 goes to 2, half of 2 is 1, half of 1 is a half of a half is a fourth, half of a fourth is an eighth, and you could try that calculation on a calculator if you want to. So using this pattern, we know that this is going to be true. Well, look then what happens when I have 2 to a power of negative 1. It is 1 over 2. And that's what 2 to the 1 is, right? 2. What about 2 to the negative 2? Hey, that's 1 over 4, which is 2 squared, which is 4. Negative exponent means reciprocal. So if I have 2 to the negative 2, I know I need to put this 2 underneath the 1, and then I would have 2 squared, which is 4. 2 to the negative 3 would be 2 cubed, which is 8, and it's the reciprocal of 8, which is 1/8. The negative exponent means reciprocal. So how does this work with a variable? Well, x to the negative 1 would be 1 over x. X to the negative 2 would be 1 over x squared. And x to the negative 3 would be 1 over x cubed. The negative exponent just means I'm taking that power, x cubed, to the reciprocal. So the reciprocal of x cubed is 1 over x cubed. Numbers again, 3 to the negative 1 is 1/3. 3 to the negative 2 is 1/9. And you can see why, right? 3 squared is 9. 3 cubed is 27, so it's the reciprocal of 27. So anything to the negative power is reciprocal. That's all it is. We'll be working with that today. How about zero exponents? Well, look here. When 2 was to the 0 power, it was 1, right? If I were to use subtraction, this would be 2 to the 4 minus 4, which would be 2 to the 0. Oops, I made that 0 tag. And 2 to the 0, we need to figure out what that is, because this is 2 to the power of 0. Well, let's just take 2 times 2 times 2 times 2 over 2 times 2 times 2 times 2. Karate. It's not 0 left. Every single one of these divides. 2 divided by 2 is 1. 2 divided by 2 is 1. What's 1 times 1 times 1 times 1? That's 1. So there's a proof that 2 to the 0 is 1. I think the power of tens is a good way to prove it as well. 10 to the 3rd is a 1 with 3 zeros. 10 to the 2nd is a 1 with 2 zeros. 10 to the 1 is a 1 with 1 zero. 10 to the 0 is a 1 with no zeros, just 1. Anything to the 0 power is 1. So we're going to be working with these two concepts today. So here's an example to try. Look at this mess. Negative 4n squared, q to the 5th, r squared, divided by 9, n to the 3rd, q squared, r. We don't have to simplify anything in here because look, we're taking all of this to the power of 0. Our solution is 1. Don't make the mistake of, on your assignment, trying to start working this out when you see that it's to a power of 0. Here's another way you might see the power of 0 today. I have x to the 5th, y squared, all over x to the 3rd. Well, y to the power of 0 is 1. So this is just x to the 5th times 1, which is x to the 5th, over x to the 3rd. And do you remember, if I have the same base, I can subtract, since this is a division, I can subtract, so this is x to the 5 minus 3, which is 2x squared. Okay? Now try the example of a 0 power in your notes. If I were to use just writing these out, this is 8 squared, this is 8 to the power of 5. If I karate, do you see how I have in the denominator 8 times 8 times 8? Well, that is 8 cubed. In the numerator, I have 1, because anything divided by itself is 1. And I can't have a 0 up here. It has to be a 1 there. Now, this makes sense because my denominator's powers, I have more of those than I do on top. So that makes sense that I would have something left on the bottom. This is how I would write 8 to the negative 3, right? because anything to a denominator here would be a reciprocal of 8 to the third, which we write in this form. The other way you could solve this is you could say, okay, this is a base of 8, so I am going to subtract the powers, and that would be 8 to the negative 3. And that would be the same. 8 to the negative 3 is the same as 1 over 8 cubed. Those are the same thing. So let's see how we could apply negative exponents here. What I would recommend doing is looking to see, first of all, is there anything that you could simplify? Any n's, p's, or r's? Simplify first, always. This doesn't have anything to simplify. So therefore, we can start rearranging. This n to the negative 5 means it's 1 over n to the 5th. So I'm going to put n to the 5th in the denominator. See how I did that? I'm not going to worry about putting a 1 up here because this p to the power 4 is actually going to stay up here. And 1 times p to the 4 is p to the 4. So I don't have to have a 1 up there. You just have to use your eraser to erase your 1s. This r to the negative 2, do you see where it is now? It's in the denominator now. So it is going to move to the numerator because the reciprocal of 1 over r to the negative 2, this reciprocal would be r squared. So this is our solution. Nothing can be simplified because you can only simplify if it's the same letter. So this is the form, simplified form. You know you are done when you have no more negative powers. In this case, let's start with our numbers. 5 has a common factor with 20. It is 5. So we're going to divide a 5 out here. So this is just going to become a 1. And this is going to be a 4. So I'm going to leave this as negative 4. See that negative in front? So I'm going to leave it as negative 4. Now I have some r's that I can simplify. This is r to the negative 3. This is r squared. So I'm going to take negative 3 minus 2. R to the negative 3 minus 2. That would be r to the negative 5. So in the denominator, I'm going to have r to the 5th. Those 3 are going to go down here to sit with those 2 that are down here. Then I have some t's. I have 4 minus 7. So I have t to the 4 minus 7, which is t to the negative 3. So those t's that were sitting down here are actually going to stay down here. T to the negative 3 would be 1 over t cubed, so I still have a 1 up top. And then this u to the negative 5 is already in the denominator, so it's going to go to the top. So this would just be u to the power 5 over negative 4 r to the 5th t to the 3rd. I just take it one step at a time. Now, if you look at the example in the book is actually going to work out each one at a time. I think you can kind of use this the way that I did. Try the example in your notes, and remember, just let me know if you have questions. All right, let's try another example of that same concept. Start with the numbers. Common factor here is 2, so I'm going to divide by 2. So I'm going to put the 5 down here, and I'm just going to leave this 1 alone because I don't know if I'm going to need the 1 yet or not. This is a squared over a to the negative 3. So this is 2 minus a negative 3, and that would be 2 plus 3, which is a to the 5th. Those 3 are going to come up here, so this is a to the 5th. Those a's are gone, so now I go to the b's. I have b to the 3 minus a negative 1, so 3 plus 1, that's going to be b to the 4th up here. That negative 1 is going to pop up here. And in this case, I have c to the negative 5 minus negative 4. That's negative 5 plus 4, really, which is c to the negative 1. So that means I'm going to have 1c down below. And that makes sense because if you canceled here, you move these 5 down, those 4 up, and karate'd, you would have 1 left below. So this is the simplified form here. If you look back and you do it piece by piece, you should be able to figure out where each of those powers go. Try the example in your notes. The last thing we're going to talk about is order of magnitude. It is a number rounded to the nearest power of 10. So let's try this example with height. Suppose the average height of a man is about 1.7 meters, and the average height of an ant is 0.0008 meters. How many orders of magnitude as tall as an ant is a man? So we're looking to see by what power of 10 would we have to multiply this to get here. And if you would look, you could look at the decimal places. each power of 10 is going to move this one place. And so your order of magnitude, you can go by powers to figure out what that might be. I'm going to put this in your notes. I want you to try to work it out, and then we can talk about it at the beginning of class.